Okay, so this is the third tutorial on Yenka. Now, again, we started off with our same starting point. When you open it up, it will ask you, obviously, I'm at home. Of course, yes, you're at home using this license. I'm not too sure what would happen if you press the other one. That doesn't matter. To start the program, obviously, you come to here and you've got, same as last time, computer, mathematics, science. We're going to be working on technology again, this one here. And again, we're going to stick with our electronic components here. Again, we started with the basics in that first tutorial, and we've gone a little bit progressive more and more, where all the stuff that we need is in this one now, okay? So same thing again, we'll click that, press OK, go to our new tab, and here we go, and it opens up with all of our usual ones from last time. Many of these folders are open because obviously I've been using them so much, but obviously when they're closed, you'll see them like this, and you can open them up to their different parts, basic, symbolic symbols there. You've got your inputs, your sensors, your switches, and so on and so forth. Now, in today's one, we were looking at obviously the pneumatic circuits, most importantly, the difference between an AND circuit and an OR circuit. And this is your opportunity now to model them. Now, the biggest thing to remember is the difference between the two of them. The main characteristic is the AND circuit consists of those two valves, those two switches. They both need to be connected, turned on for the circuit to work, and then obviously for it to activate the cylinder in this case, or it can be some other things that I'll show you some examples there as well. And then the OR circuit, again, same thing. You've got those two cylinders, those two switches. Only one needs to be switched for the actual activation of it. And again, there are other examples for that as well. It's not just to activate a cylinder as a pneumatic system, as I'll show you, there's some other examples you can do here as well. So as a quick little model, just to go through this, I don't want to spend too long on it. I want you to have the opportunity to have a play around of it. I'm going to go into, I'll start off with, you know what, actually, we're going to start off with our battery, because we're going to need a power source on this regardless. There always needs to be a power source. So I've just thrown a battery power source in there. And we are now going to need two of these. So I'm going to put one here. You'll notice this is similar to the switches we've used before, but these ones have a little bit of a different connection on them. And I'm going to explain why they are relevant in this case in a minute. And we're going to use this one over here. And I'm going to right-hand click that, go to properties, and I'm going to just turn it around so it's facing the other way. This is quite important in a moment. So I'm happy with that. I'm going to keep that there. And I'm going to go down here. I need to have a cylinder. Closest thing pretty much to a cylinder on here is, we'll go down into our mechanical systems. Solenoids are pretty similar to what we have working here. We've got kind of a solenoid, a kind of a pneumatic pump similar to a cylinder. It's not exactly the same, but for the purposes of obviously this modeling of the circuits, it will do what we need it to do. So let's start off with the OR circuits, because there's some good little examples I'm going to use here. So for that, I'm going to put these this way round, okay? So it goes like so. I'm going to connect my little solenoid, or my cylinder in this case, round like that. The other end of my cylinder around down to the power over there, and that power bit over here. Now, this is the important bit. I'm going to connect that to there and that to there. So this is our OR circuit we're talking about. Now, you'll notice that as it is currently not connected anywhere here, the solenoid is obviously pointed outwards, the cylinder is shot out, it's not connected whatsoever. Now, as I switch any one of these switches, it doesn't matter which one it is, all I need to do is switch one switch, completes the circuit. And as you can see, the solenoid there, or the cylinder, has obviously been activated, it's pulled in this sense. I can click any switch, I can click the same switch again, and as you can see, it's turning it on and off. I'm only activating one switch to make the circuit work. So this is literally just the one valve I'm pressing. So the OR circuit has those two on there, but you only need to press one. And I can go over here and change that as well. I can even flick backwards between the two of them. Now, this particular layout works for a number of different things. You might have somewhere in your house, I'm sure, a situation where you have a light switch that is, a light that is operated by two separate switches. And it doesn't matter which switch you turn on, it will activate that light. This is the same principle. So I can even take this here, I can delete that. I can go in and I can use the same principle behind this OR circuit here to put a light bulb in. So this kind of logic gates of the ORs and the ANDs, this is the same principle here. So there's my bulb, it's turned off. Let's say it's a light switch on a set of stairs. So you'll have a light switch at the top of the stairs and a light switch at the bottom of the stairs. As I'm at the bottom of the stairs, I will turn the light switch on because I want to be able to see as I'm walking up the stairs, and I walk up the stairs and I get to the top and I want to turn the light switch off. And then I can go to bed, and if someone's upstairs, they can go back there, they can turn the light switch on, they can walk downstairs and they can do the same thing. But then if someone else wants to come from this direction, it still works. No matter how many times you press it going in whatever direction, you can keep going that way around. You can keep going that way around. 3 or 4 people have walked up the stairs now. It still works. And then 1 or 2 people walk down the stairs and it continues to work. So the principle behind it is the same. You only need one of those switches to be pressed to either activate it, turn it on, or activate it and turn it off. Now that was the example of a light switch. I could do the same in various other reasons. I'm using my solenoid here to represent my cylinder valve, which is the main point of the pneumatic circuits that we've been looking at here. But again, as I mentioned before, it can work in a variety of different ways. So that is our OR circuit. I could take a screenshot of that and then just explain that as a simple OR circuit point there. In order to make that the other way around though, what I need to do with these is actually flip them. So I'm going to see if it will let me do it. It might mess up the wires. I might have to just delete them and put them in again. Yeah, it's not going to like that. Right, I'm just going to go ahead and delete them. Right, this time I need to bring those in again, but have them facing in the opposite direction. When it does that, it does the, well, literally the complete opposite. And it will become an AND circuit. So properties, let me rotate that way. Now this time, they are, if you think of them as little kind of crocodile mouths, I guess, they are now facing out from each other. So if I have them both turned off, it's no good. I need to make sure that both are turned on for the circuit to activate. It's no good just pressing one of them, because all that's going to happen is if I have the other one unselected, like with the light switch on the previous one or the OR circuit, I could happily press one of them and it would keep working. However, pressing one of them is no good here. I've only activated one of my valves. I needed both valves activated together to activate my cylinder here. So this is a simple example of the opposite or the inverse, which is an AND logic gate. Okay. Again, once one of them is turned off, it breaks the whole circuit. I need both of them activated in order to be able to work the circuit. That's a very simple example. You can take another screenshot of that, and that is your AND circuits as well. Now, they're normally not kind of flip switches like this. You could probably even, I'd say that maybe a, oh, here we go, a push to brake switch would probably be better, because these two are probably a little bit closer to what we would consider to be a kind of a valve button, where you've got this idea of the two switches are switched on, and all it takes is for you to press one of them and it breaks the circuit. Now consider we have a similar thing in our workshops when we are doing practicals. You might have, say for example, someone over here using the pillar drill, and as you can see, it's activated, it's on, the pillar drill is running, and we have emergency stop buttons around the classroom, in order for if someone sees an emergency somewhere across the classroom, they can instantly cut off power to everywhere. So the minute one of these is pressed, it cuts off power to everything. It's another example of that kind of the idea when we have both of them that need to be pressed at the same time. So that's the AND circuit there. As long as one of them is broken, it's no good. And that's a simple example of your AND and your OR circuits. So you can model both of those, get a little screenshot of them, and explain how they work.